Hello everyone, I'm Xiangcun Fu from Red Hat. I will work with Pei Zhang together to present the fraud detection using computational container on BM TDX with OpenShift AI demo. Before the demo part, I would spend a few minutes to give an overview of what the demo will show, what fraud detection is, and the deployment topology. Next, Heijang will share the demo details. In this demo, we will use trustee to decrypt an encrypted model, which runs in confidential container with TDX. Like the left picture shows, we deploy an OpenShift cluster with CoCo on the TDX environment. An AI model will be served in the pod inside a confidential VM. We will use Kata CC TDX runtime class. This will run the workload in a trusted execution environment established by Intel TDX. There are 3 steps to serve an AI model. The first, we need to download an encrypted model from storage. The second, we need to get a key to decrypt the model. How do we get the key? It will request secrets from the trustee key broker service, means KBS. After getting an attestation token, the KBS will return the secret which contains the key, and the encrypted model can be decrypted. Finally, the decrypted model will be able to serve. The right picture, AI model is directly served in the mode without computational VM. It's using runC runtime class. It will also request secret from the trustee KBS service. However, this workload is not protected by the Intel TDX, so it fails to get the secret from the KBS and the model. The model cannot be decrypted, so it cannot be deployed successfully in non-TEE environment. Okay, so this picture shows the key point of the demo we will present next. Next we will introduce fraud detection. In our demo, it's an AI model which predicts the credit card transaction for potential fraudulent activities. It analyzes the credit card transaction data, including geographical distance from the previous transaction, the price of the current transaction compared to the median price of history transactions. This user completed the transaction like using the hardware chip, PIN number all online, and others. By analyzing such data, the fraud detection AI model will output if the current credit card transaction is a fraud or not. For more information about the fraud detection, you can get access to below workshop link for more information. This page shows the three phases of AI model in the OpenShift AI. The first phase is developing and training AI model. The second phase is uploading AI model to storage from local. After the model is trained ready, the third phase is downloading the model from the storage and serving it. We will have three pods to run workload of these phases. How about adding TDX and CoCo attestation with model in the OpenShift AI? Compared to the formal page, you can see the AI model is encrypted. After the model is trained ready, it will be encrypted by using a key, and the encrypted model will be uploaded to the storage. At the model serving phase, after the encrypted model is downloaded, it will need to decrypt before serving it. Like introduced in the first phase of this slice, the key will be acquired from the KPS service after it passes the attestation check. That's all. The slides part. Next, hand over to Peijiang for the demo part.
Okay, thanks Xiangchun. So let's get back to the demo part. After we log in the OpenShift web console, let's say the operators we have installed, including the OpenShift AI, OpenShift sandbox containers, Red Hat OpenShift serverless and service mesh and trusted operator. After all these operators installed and configured ready, let's open the OpenShift AI web console. Let's click it from here. The OpenShift AI page is downloading. Okay, so logging into this page, we need to create our data science project first. Currently, we don't have one project yet, so let's create one. Let's name it fraud detection, and the resource name is fraud detection. We will have our new namespace called fraud detection. All the pods and resources will be created under this namespace. Okay, let's create it. In the data science projects page, there are several tabs including the overview, workbenches, pipelines, models, cluster storage, data connections, and permissions. So we will give a simple introduction about which we are used in today's demo. The workbench, it's an isolated area where you can develop and train your AI model. The models is after that your model is trained ready, you can serve your model here. The data connections is our storage. After you train your model locally, you can upload your model to a storage so that this model can be get accessible from anywhere. Okay, so next we will create our storage first. Let's switch to the terminal. Okay, I will create for the bare metal. We need to create a persistent volume first before we create the S3 compatible storage. We are creating the min IO in our demo. Yeah, let's create it. And also we need to set the permission of this directory because we use the host path of the storage. Let's say what's the PV3 looks like, and yeah, you can see that it's a persistent volume, and it uses the host path. It's using a local host path as the storage. Um, regarding the S3 YAML, actually this YAML file is from the fraud detection AI model, like Xiangchun has introduced in the slides. There is a open fraud detection AI workshop, so we can just click it, and here is a YAML file which we can create S3 and create S3 buckets, and something like that. All of this has been set up in this YAML, so we can use it directly. Okay, so the storage has been created successfully. Now let's check the pods, the related pods. Let's switch to the fraud detection in a project, and let's say the pods. We can see that the MinIO pod is running compared to the topology that this part has been ready. Okay, so next we will create a workbench. Then workbench is an area where you can develop and train your data. Let's call it fraud detection, the workbench name, and we choose a notebook image as a TensorFlow, and we choose the related version, the container size, and also we need to choose the cluster storage, this one, and for the data connections we can use the data connections we created already, which called the my storage here. Okay, so let's create it. For the cluster storage, we also need to create a PV. This is only for the bare metal deployment. So let's create it, and meanwhile, let's create another PV. Let's copy and running these commands. Also set the permission of the host path. It's not existed yet. Let's say the pods. Yeah, it's pending. Okay, let me set the permission to it. Check the file exists. Let's set the permission. Okay, it sets successfully. Let's get back to the pods. Yes, it's running. So compared to the AI phases, we can see that this pod has been set up ready. So the first phase and second phase has been ready. Okay, let's open the workbench. Let's open the Jupyter environment, which we will develop and train the model. So the pod is running. We just open this environment to develop and develop the model and train. Let's copy the password. Okay. Okay, let's open it again. Yes. So the Jupyter lab is downloading. It will take a few seconds. During this time, I would give a simple introduction about the Jupyter lab. The Jupyter Lab is a web-based interactive development environment for the notebooks, code, and data. So it allows users to configure and arrange workflows in data science, scientific computing, computational journalism, and machine learning. So it supports many languages and kernels, and just in our demo uh, we will run the AI model repo with Python language. So this is a simple introduction about the Jupyter Lab. And the Jupyter Notebook is the original web application for creating and sharing the computational documents. It offers a simple, streamlined, document-centric experience. Okay, so the Jupyter Lab is opened. Let's copy the fraud detection AI repo. I'm using the repo of the Emmanuel. He added some CoCo parts, so let's clone the repo. Okay, sorry. Okay, let's clone the repo. You can see in the fraud detection repo there are several documents including the assets, the CoCo parts, the data, setup utils, and it also includes some code file which we will run directly. So let's open this one experiment train. In this code page, it's mainly developing and training a model. So let's start running at the beginning. Install the Python dependencies. This fraud detection is written with Python language. So let's install the dependencies and import the dependencies for the model training code. Okay, and let's load the data and build the model. Okay, next let's train the data. This will take a few minutes, so it will take a few minutes. You can see that the training is still in progress. So I just fast forward this step. You can see that the training will be finished soon. Now the training of the model is complete. After the model has been trained ready, we can save the model locally. Let's save the model. Let's confirm the model file was created successfully. Actually in the repo here, you can see we have our new models created seconds ago. It includes the model data. Let's test if the model works as expected. Let's load the data. And let's show the results accuracy of the model. It works as expected. Okay, so this part is an example, is checking if Sally's transaction likely to be fraud or not. Here is the data. The distance from the last transaction, the data is 0.3, and the price ratio to the median price is 1.9. Sally is using chip and didn't use a PIN number, and it's an offline order. So based on this data, let's see how the AI models tells if it's the AI's prediction. The answer is that the prediction is not a fraud. How likely was Sally's transaction to be fraudulent is very, very low data. Okay, so up to now we have been developed and trained a model, and we saved a model to the locally. Next, let's encrypt the model using the key. Let's encrypt it. Yeah, the key is here, key.bin, and it's using a fancy to encrypt the model. The model is encrypted successfully. Yeah. Let's say the model. Okay, let's should be here. Yeah, we can see that here we have two models, the original model and an encrypted model. We remove the original model and we just keep the encrypted model. So now you can see that we have only one model in the exists. Okay, so up to now in this page we have trained a model, and we have saved the model locally, and also we encrypt the model, and we only have an encrypted model in the local directory. Okay, so this is current status. Next, we will save the model to the storage. To save the model to the storage, so that you can use it from various locations, including other notebooks or the model server, and we need to upload it to S3 compatible storage. In this demo, we are using the min.io. Okay, let's install the packages and upload and verifies upload. Yeah, let's show we can see that the model has been uploaded successfully. Yeah, it has been uploaded successfully. So up to now, we have trained a model and encrypted the model, and the encrypted model have been uploaded to the S3 storage. Okay, next step, we will serve the model. Let's serve the model by the single model serving platform. Currently, only the single model serving platform supports the runtime class change, because we will change the runtime class from the runC to the kata cc TDX. Let's deploy the model. Let's call it fraud. Serving runtime, we choose OpenVINO. Let's choose a model framework, and model location. Let's select the S3 storage, and the model existed in the models fraud directory. So let's copy it. Let's deploy the model. Okay, the model is deployment now. Let's switch to the pod part. We can see that here is the pod of the model serving pod. Let's open it. We can see the init, it hit errors. This error is expected. This is because let's say there are several containers and in this pod, and I will only focus on introducing the init container, which calls the storage initializer. This storage is mainly focused on is responsible for download the model from the S3 storage. So let's see logs of this container. Currently it hit errors. Sorry, it's not here. Should be check the log here. Let's switch to the storage initializer. In this log, you can see that the model has been copied, had been downloaded successfully, but it hit errors. It hit errors when when decrypt the model, as the model is encrypted, it will get key from the KBS service. Once it retrieves the key from the KBS secrets, it will hit errors because in these workloads it's not using the TDX and it's using the RunC, so it's not, the workload is not running a TE environment and is not protected by the TDX, so that's why it will fail to get a key. So this means that the encrypt model cannot be decrypted successfully, so the model will not be able to serve successfully. Yeah. Next, let's switch to the Kata CCTDX. Let's switch to this runtime class. Okay, we need to do some small changes. First, we need to let's change the mode. Let's change the OpenVINO version. This is because in our deployment we found that with this image the container cannot start up. We hit errors, so we just replace the versions with unworkable one. And let's copy it. Another change is that we need to change the inference services port with change the runtime class, and also we need to disable the sidecar still sidecar. Also, same reason, we hit errors, we hit segments faults during the deployment, so we just disabled it as a workaround. Okay, next let's add the runtime class name, Kata CCTDX. Okay, that's all the changes we need to do. Get back to the pod in the OpenShift. We can see that we have another new fraud predictor pod, which numbered with 02, and it's in the init phase. Let's switch to the KBS deployment pod log. Because in the when the init container is the process are similar, the process are similar with the RunC download the model from the S3 storage and decrypt it. The difference is that with the runtime, with the Kata CCTDX, the key will be able to it will be able to get the key. So let's see how the KBS shows. You can see that get resource from the KBS, get the key domain from the KBS and get successfully. So the resource access request passes the policy check. So this means that with the Kata CCTDX, the storage initializer container, it can get the key from the KBS. So let's check the logs of this container. Let's switch to the storage initializer. You can see that this step are same. It copies the model from S3 successfully, and it downloads the key. It downloads key from the KBS, and you can see that it gets the key successfully, and the model is decrypted successfully. So this means that with the Kata CCTDX, the encrypt model can be decrypted successfully with the key which is acquired from the KBS service. Okay. Okay, let's get back to the pod status. It's still pod initializing. This will take a few minutes. This is because the images of the containers in this pod is super large. The total size is about 7 GB. So the confidential VM is also very large. We set up with 32 CPUs and 120 GB memories, so it will take a bit while to start up. Okay, during this time, I also will show some logs or setup. Let's say this is the worker node terminal. Let's check the QMU command line. And you can see that here is our QMU command line. It's including confidential gets supported as TDX, and there are also the TDX object and more setups. So I will not show every details, just like show that this is a QMU command line of the confidential VM. Okay, another setup is okay, now it's running successfully. So let's just check the YAML file and to confirm the runtime class name. Here you can see that the runtime class name is a kata cc TDX. Okay, so that's the pod which serves the model. So up to now we have all three pods running successfully, and we will switch to the last step. We will test the inference endpoint. Yeah. Let's open the after the models is served successfully, we will get an inference endpoint. Let's copy it, and in the Jupyter environment, let's open this scripts and run the inference endpoint. So let's copy it and paste it and run its deployment model as we created as a fraud. And let's run the command request functions. This is the prediction data, and it's not fraud. Okay, here is two examples. The first example is that the user buys coffee, and the data is like this. It's the same location as the last transaction, distance is 0, and the same median price. The current price the ratio to the median price is 1. The user is using the PIN number of the credit card, and it's using the chip, and it's not online transaction. So based on this data, let's see how the AI predicts if it's a fraud or not. Yeah, the model thinks that this is not a fraud. Okay. Another example is that someone stole the user credit card and is buying something online. The data looks like this. It's very far away from the last transaction. The distance is 100 kilometers. Let's say it's similar median price. The ratio to the median is 1:2, and the user is not using chip, not using the PIN number, and it's an online transaction. So based on this data and the AI predicts how the AI predicts, let's say here the model thinks this is a fraud. Yeah. So I think that's all the demo part. Thank you for your watching.